Hi everyone, my name is Munyard and I'm a system architect at TechnologyOne in the research and development team. My presentation this evening is about how we maintain our developer ecosystem, which are the tools a developer uses to do their job and the processes that they follow to develop and deliver software. When I was thinking about what talk to give, I thought I'd choose this one because you might find it describes the company that you'll work for once you leave university, because TechOne is fairly representative of a software development company that has been around long enough to experience multiple evolutions in the industry. Like most software development companies, we started out as a desktop application. Our customers were installing that manually onto every single user's machine. They were called fat clients. But today we are focused completely on delivering that same application that we've re-architected to run on the cloud, in the browser, software as a service. As part of focusing our business on SaaS, we changed our primary language that we develop in. We went from VB.NET to C#, and we introduced a build system and we upgraded the IDE. However, when you have an existing product that your customers rely on to do their business, it can take some time in years to migrate it all to the new application. So while it is common for companies to be delivering a modern product in SaaS, they still need to support their existing application. For TechOne, this means that we have more than 200 developers working on the new and quite a few developers still working on the existing. So when it comes to creating a developer ecosystem that suits everyone, you can't just consider what's best for the team developing the new application, because you also need to consider the needs of the team supporting the existing one. So I'd like to share how we manage this transition and balance and compromise at TechOne, and I'll try and relate that to what your experience might be like when starting work in the industry. So we'll jump straight in, and we'll start with a very high-level overview, which is the developer ecosystem at TechOne. Now the logos and the combinations are going to be specific to how we run at TechOne. But at any company you join, you're going to have the source control system, you're going to have somewhere to document things, you're going to have somewhere to raise your issues and track your time, you're going to have somewhere to run your code, probably even deploy it from the same place, and then you're going to have your workspace. And that's where you'll have your IDE and probably somewhere to test your code locally before that you push it up and deploy it to the customer. For TechOne, we really use the whole Atlassian suite. We use Bitbucket for Git, Confluence for documentation, and Jira. But then we use a product called TeamCity for doing our CI/CD. You probably have heard of Jenkins and Travis CI. They're an equivalent product that do the same thing. When it comes to deploying, we have built our own tool to do that in the cloud. And then for our workspace, I'm not sure if this is unique or not, but we use a managed remote desktop service called an Amazon Workspace. If you know what a remote desktop is, it's like that, but managed by Amazon completely. You just tell them how much capacity you want in the service, and they'll provision that for you through an EC2. Each developer has one of those that are dedicated per developer, and then inside that workspace is where they're developing with Rider as their IDE, and they're testing on a local IIS web server on a shared database with their team. So I think it's fair to say that that's a fairly modern setup, fairly modern ecosystem that we find ourselves in today. There are parts that new developers, especially like yourself coming and joining the company, find difficult, especially getting set up in that workspace, knowing how to configure the web server. And I'll talk a little bit about that at the end and how we're trying to solve that. But this talk is about some experiences we've had in maintaining this ecosystem, and I'm going to take you back 5 years ago to show you what it looked like back then. It was a little bit different. Back then we used a product called TFS for our source control. That was a Microsoft, probably still is a Microsoft product for source control, but it was online. And what that meant was you had to be connected to the internet, the server had to be connected and had to be online for you to be able to write code. What that would mean that if someone tripped over a cable, turned that internet off, or the server went offline, you went offline, and your IDE would freeze until it came back up online. We had remote desktop similar to what we have today, but the problem was it was managed by us. We just spun up a bare bones EC2, we ran the remote desktop service on it, but we shared it with 4 developers. If you're looking at that, what could go wrong? Well, I can tell you, if a developer had too many applications open, they had a bug in their code that was causing a memory leak or too much CPU usage, you were taking out 3 other developers. And finally, we use Visual Studio to do our development. Now that wasn't a particular problem, but we were having a lot of productivity issues with outages, especially around the remote desktop and the TFS side. This whole ecosystem at that time was being maintained by a dedicated team of technical engineers. So that meant they were technical, but they weren't developers. And the problem with that is they weren't using the tools that they were maintaining. And we would often have developers raising support tickets saying, oh, it's really slow. And the support team closing them saying, well, I can't replicate that, because they weren't using them the same way a developer uses them. And that's because, as you know, you're multitasking. You're not just developing and then waiting for it to compile. You're then looking at the issue tracker, you're checking out your builds. We just didn't have a relationship there that they could relate to how we were using the software. The other major issue that started to surface with this ecosystem was that the scale of TechOne, as we were growing and hiring more people and doing more builds and doing more releases, is our systems weren't scaling. We ended up getting to a point, one release a few years ago, quite an infamous incident inside the company, where we were trying to release one of our half-yearly SaaS releases, and the build system and the source control system really wouldn't stay up for any more than half an hour. And by the time you got your build through to meet the deadline the next day, you'd been up all night. So when developers came to work next day angry, there had to be something done about this. So the first option we had was, well, let's just hire more people into that technical engineering team I mentioned, and we'll scale out that team. But they were really putting band-aids on patches, and that weren't really fixing the core problems of the system. The people that knew what they wanted were the developers and the testers, the people that used the products. So we had an alternate idea, and that's kind of what I want to talk to you about in this presentation today. We created this concept of a team of teams. And in this model, involved creating teams of volunteers who had ownership of a particular component in that ecosystem. They could choose what they wanted to improve and were given ownership to make those changes. The teams were encouraged to collaborate with each other, especially when a change that they were making impacted on another system. And I'll give you an example. When we went from TFS to Bitbucket and Git, we had to make a change to the build systems to start cloning from Git rather than checking out from TFS. When we went from Visual Studio to Rider, we had to make a change on the build server to use an open source compiler compared to the one that was embedded in Visual Studio. In the first year of this project, we made 2 really significant changes to the ecosystem. We moved from TFS to Git, and then we moved from Visual Studio to Rider. And the TFS to Git project was run by someone who joined us from UQ. So in TFS to Git, it was definitely the most ambitious. When I told you about TFS, I wouldn't blame you if you've never heard of it before. I really hadn't before I joined TechOne. And it really wasn't a product that Microsoft were pushing too heavily, because as you probably know now, they work completely on GitHub. The problem with it though was a legacy application that we were trying to convert to Git. And the challenge was going to be how we were going to convert the structure in TFS to what it needed to be in Git. Really fortunately for us, someone had written an open source tool that did the conversion for you, and it automatically converted a TFS project to a Git repository. And this worked really well up until it didn't. And what had happened over the years in a company as big as TechOne is that we'd been following a really clever development branching strategy, branching, committing on that branch, and then merging back into the mainline. But really when things got a little bit out of control and you had to break the glass, TFS let you go and edit that commit history at any point back in the commit without having to do rebasing. And what would happen is the tool would try to convert the code, it would come to one of these custom edits and it would completely fall over. So to remedy this, the team of teams wrote a tool that was wrapped around this open source one that was introduced to apply TechOne specific logic where a conflict was encountered. The team of teams wrote this wrapper and documented it and communicated it really clearly to the teams. And they did this to ensure that the staff perceived the project in a positive way rather than something that was being forced upon them, particularly when they didn't know what Git was and why TFS was broken, and so why fix it. The key to the success of that migration was that we clearly articulated the benefits of the code base once it was migrated. And these weren't all necessarily technical. And you'll find that in most cases that when pitching an idea that you want to become a project, you need to explain it in non-technical terms. Think of the audience that you're pitching to and explain it to them in their terms. And I think too often we love our technical jargon and we like to use it, and I see people get lost all the time in a presentation, even if it's to technical people. The second really major change for us was converting from Visual Studio to Writer. The reason why we did this was that traditionally TechOne has been a Windows desktop application and therefore runs on Windows, and so all of our ecosystem is Windows as well. But when you move your application to the cloud, typically you're not running on Windows, you want to run on Linux. In our case, we're hiring staff who code in C# and who traditionally only know Windows. And that was because .NET only ran on Windows. And then about 4 years ago, Microsoft started to change. And they announced that they were going to rewrite the .NET framework and call it the .NET Core. The biggest change was that it would not only run on Windows, but also Mac and Linux. And my theory on why they did this was that at the time, SaaS had really taken off and cemented itself as that de facto method of delivering software. And Microsoft saw that developers would not even go near .NET because it meant running on Windows, which meant paying for using the operating system on top of your hardware costs. And they could realize that if they didn't provide a cross-platform version of .NET, that they would only be relevant in that desktop application space. So they really started focusing on .NET Core, and they moved it completely open source and started working on it in GitHub, which at the time was really unlike Microsoft. Since then, they've moved more and more of their closed source to GitHub, including the .NET framework that we used, even though it still only runs on Windows. But this is a major shift for them. That meant for TechOne, we could really see a change coming and an opportunity as well. And that we knew that Microsoft were going to invest all of their time into delivering .NET Core, and eventually they made this public when they announced that .NET Core is the future of .NET. And the writing was on the wall for us. In terms of how that would affect our developer ecosystem, we knew that we could start to write code that would run on Linux as well as Windows, all from the same code base. But we saw a problem was that Visual Studio only runs on Windows, and we needed another IDE that could run on both Mac and Linux and Windows. Visual Studio Code was the most obvious choice that came up, but unfortunately for us, sometimes that most popular obvious tool is not suitable for an organization for some non-technical reasons. We have hundreds of developers who are productive in using an integrated development environment, and they don't want to move to a new IDE just because one day we may run on Linux. So very early on, we drew a line through VS Code. And then focus kind of narrowed down onto a cross-platform .NET IDE, which is very much a niche space. There was only one option out there that was going to provide an equivalent experience to Visual Studio, and that was JetBrains Writer. However, at the time, it was only released in alpha, and you had to take an update every month if you wanted to be on that program. So it clearly wasn't going to be suitable to roll out to 300 plus developers at the company. So what we did was we formed this team of teams, and we filled it with volunteers of people passionate about using a cross-platform IDE, and they started to use it as their primary IDE day to day. They started to feedback bug fixes and reports to JetBrains, and started to progress it towards a mature product that we could use at TechOne. However, what came really clear to us very early on was that when you live inside of a vendor's ecosystem, such as what Microsoft provided for .NET, everything just works really well. It just works trademark. But when you started to step outside and you do something yourself, things start to stop working. And for us, this was the compiler. We didn't realize that Visual Studio had sort of embedded their compiler and had made the code just compile. Who would have thought it would have been on the IDE to do that? It turned out that Visual Studio had been augmenting the compiler with features that only existed within Visual Studio. And over time, developers had naturally embraced these features in their projects. And when we started trialing Writer, those projects just didn't compile. But because we were trying to convince developers to switch, we worked really hard on a conversion strategy that clearly documented the steps for removing the incompatible code. And one thing that I learned from doing this project and that I can share with you is that on average, developers really like things to be written down rather than spoken to them. You can do both, but ultimately it still needs to be documented. There are two reasons for this. Developer instructions typically involve multiple technical detailed steps, and they're not going to remember everything that you tell them. And the other reason is that developers like to try things themselves. But by us going through this process of understanding how to build our code, we had a much better understanding of what actually was happening in our developer ecosystem compared to before. And when it came time to upgrade our build server to remove Visual Studio and start using an open source compiler, we were ready for that too. Previously, a user would have logged on manually to our build servers, kept them up to date by installing some new dependency or version of a dependency, and then taking a snapshot of that and updating the server farm. The biggest problem with doing that is that in that approach, that person who does the upgrade holds all that information. If they were to get sick or to resign, we really don't have a way to keep our business running and our agents up to date, and that's a major problem. So at the same time, the team of teams with fresh perspectives from people coming from university was we started to automate our infrastructure as well. In this approach, we code out all of the steps it takes to build up our infrastructure. We use AWS to run those scripts to build up servers. Then we take a snapshot of them, known as an Amazon Machine Image or AMI, and we store that in the cloud. We then use CloudFormation to roll out a new AMI and let the AWS cloud take care of updating our infrastructure for us. It's a much more modern way of doing things. Going through that process and documenting it in code, what we were doing taught us a really valuable lesson. If a tool in your ecosystem is critical to your operation, then you need to understand how it works. In our case, MS Build, the compiler, it just worked, but only because of Visual Studio. When we took it out of our ecosystem, things stopped working and we didn't know why. And it took us a lot of time and effort to get on top of that. The process of converting to Writer taught us a lot about the compiler, and as a result, we were able to remove a lot of unused and unnecessary code. And maybe the biggest benefit in all of this is that it now has allowed us to make some really important critical changes going forward and really getting ahead of the curve for once. So for example, I mentioned earlier that developers who join TechOne still have a problem with getting started. They've got this ecosystem and they want to know where they fit in. In particular, I want to write some code and I want to test it and I want to see what happens when I run it. And we've noticed that setting up the web server, connecting to the database, putting the software in the right place really isn't as simple as it could be, even if you document it. And it's really clear that containers solve that problem for you by packaging inside the Docker image the application dependencies and the application code itself. Then you're just building software and deploying it into an image. By having gone through the team of teams process and using experts to sort of get us to a point where we understand our ecosystem intimately, it's given us a means to adopt an industry trend where it makes sense to do so. The other really important thing with updating your ecosystem constantly is that you build a culture that is familiar with frequent updates. It's not such a big deal to keep evolving the system in that way. But if you let that ecosystem go stale and fall behind on keeping the system up to date, then upgrades will usually include more breaking change and put everyone off doing any updates at all. And this is what I call a death spiral, and one that you will want to avoid by maintaining a healthy ecosystem, and one, if you find yourself in one, a lot of effort to get out of. So for us, the next big change is going to be to adopt containers for more and more, starting with testing our software. We plan to use Kubernetes for our orchestration framework and use containers for rapid turnaround on testing those code changes. That's going to be a really major change for us, but one that was possible only because we intimately know our build pipeline now and can move it inside the container. And 4 years ago, that just would have seemed impossible until we introduced the team of teams. And that's all for me. Thank you. I'll just answer some questions from James. He asked, how was debugging change moving from Visual Studio? Well, I suppose that was one of the things that didn't work straight off the bat when we first moved to Writer. We noticed that, in particular, they weren't able to attach to a .NET process, which is kind of crazy when you think about it being a .NET IDE. So we ended up writing plugins that would find the .NET process that corresponded to the web server and attach it to that manually. We ended up feeding that issue back to the JetBrains team and saying it's a bit crazy that this feature's missing, and they added it within the next release. In terms of how debugging has changed in sort of attaching a breakpoint, it really is the same, but the experience was far more inferior to Visual Studio when we first started. And we definitely had a lot of feedback from teams that it wasn't a good enough replacement. And so we worked really closely with JetBrains to sort of feedback our developers' experience. And we used the weight of numbers at TechOne to say, this is really causing pain for 300 people. Can you do something about it? But it's fair to say that for about a year, it really didn't match Visual Studio's functionality, but it definitely does now. And it's got some awesome features that we definitely have just discovered recently, like conditional breakpoints and breakpoints that get hit only if a previous one has been hit as well, which helps greatly with recursion. How receptive have JetBrains been to requests for bug fixes and new features? Not too bad. Especially with Rider, it's a new product for them, and well, newish. And so they've been fairly good on that front. Like I mentioned though, we use TeamCity, and that's a massive product and it does everything for everyone. It's a cross-platform build system, and in that case we've had some issues, particularly with breaking changes that have affected quite a few thousand builds of ours. One of the worst was our build counters we use as our versioning for our products got reset back to the number 1, and that caused us to go backwards for quite some time. We've been able to develop a relationship with our customer account manager who can escalate things for us. But again, we didn't have a relationship with them before we started the team of teams. But we intentionally reached out to find out who they were and said, look, we're the development team. We can give you direct feedback on the product if you're keen to work with us. How have these changes impacted the development cycle, time to deploy changes at TechOne? So I think at the moment, that's still about the same. However, the Kubernetes using containers is really going to change that up for us. At the moment, we do daily SaaS deployments internally for ourselves. We run our cloud, obviously for the customers, but we run a copy of it internally as well. And we run a copy of it for every single release that we support, which is about 12 in total. Building those takes quite a long time, and we're going to look to use containers to replace the deployment from bare bones EC2 to Kubernetes using Kubernetes. How has the transition been moving from .NET Framework to .NET Core and preparing for the future introduction of .NET 5? So that one's been very rapid. .NET Core came out, I think, version 1, and then it came to 2 very quickly, then 3, and they've been deprecating the prior versions as they go along. So we currently run .NET 4.7, and we're converting to what's called the .NET Standard, which is this middle ground Microsoft are providing where you can convert to the .NET Standard. It'll run on both .NET 4.7 and .NET Core. Our plans are that we're going to hit the .NET 5 because that'll coincide with when we're ready to move to it. However, like I mentioned, we've got these on-premise customers who are currently installing the software themselves, and when we go to .NET Core, we're planning to do a cross-platform go to Linux at the same time, and that really isn't going to work well for the customers. So we need to manage them first to make sure they transition to the cloud before we make any major changes to the .NET framework. But .NET 5 would be the current goal.
Okay. Well, thank you very much for coming along. I believe I'm in the frame. I'll give you a mug that you don't have to give back. This is a little thank you from us.
Oh, wow. Thank you.
Thank you for coming along.
No
it was very insightful, learning how one of our biggest hirers of our community members operates at this scale.
Nice. Yeah, thanks for inviting me along.
Yeah, awesome. Thank you. Join us next week. We'll have a computer vision workshop, and we'll be talking about Jekyll for running your own personal sites. This Thursday, we've got a collaboration with the Student Energy Network talking about AI for power grid management. Thank you all, and have a nice night.